Welcome, everyone. Thank you for joining us today for our webinar, How MQTT 5 Makes Difficult IoT Use Cases Possible. I'm happy to introduce you all to our speaker for today, Florian Raschbichler. Florian is head of support at HiveMQ. He has years of first-hand experience in overcoming challenges of achieving reliable, scalable, and secure IoT messaging for enterprise customers. As the head of support, he helps customers succeed in introducing new technologies to the IoT space and creating business value to the end consumer in an increasingly connected world. Florian, thank you for taking time and being here today. Before we get started, I would like you all to know that we are recording this session and all participants will be on mute. If you have any questions during the presentation, feel free to type them into the QA box in your control panel. We will answer them during the Q&A session at the end of the webinar. If we cannot answer them all now, we will answer them at a later point of time. Now, without further ado, I will hand over to Florian. Welcome, everyone.
Thank you, Cheshire, for this awesome introduction, and I would also like to welcome everybody to this webinar. I see we already have quite a crowd, so let's get going. So just for reference here, so we will be talking about MQTT 5 during this webinar, and particularly a certain set of features. So I will not go over MQTT as a whole during this webinar. I hope and assume everybody knows that MQTT is the de facto standard communications protocol for IoT use cases. And when it comes to MQTT 5, we are talking about the latest release of the MQTT protocol. It was actually the first review release was in 2019, and in 2020, the official Oasis release as MQTT 5.0 happened. So it's still quite fresh. And when introducing MQTT 5, the Oasis Technical Committee, which HiveMQ and myself were also part of, had a few goals, and these goals are enhancing scalability for really large scale systems, also introducing a better error handling, allowing building more robust systems and getting more visibility into the protocol itself. Also, cloud native computing and the scalability challenge with it were a concern when introducing new features to the MQTT 5 protocol. Some common patterns that were already used amongst the users got introduced. You will see an example during this webinar. And also on the other end of the scale of the very high scale cloud native broker implementations, also there were performance improvements for smaller clients when we talk about stuff like sensors or even small edge computing devices. Here are some of the use cases that we are familiar with at HiveMQ that use MQTT and also MQTT 5 already. So we have the connected cars, we have home automation, manufacturing and automation. Transportation is something that gets more and more popularity based on what I see from our customers and prospects. We have logistics, of course. MQTT can also be used for chat applications. Very famously, little anecdote here. So one of the first known MQTT use cases actually back in 2011 or 2012 was made known that the Facebook Messenger actually has quite a substantial amount of MQTT implementations within it, which is certainly one of the biggest chat applications I would estimate out there. And of course, all kinds of mobile applications these days, be it ride hailing as one example, utilize MQTT to communicate devices these days. Now, here are the example features of MQTT5 that we are going to be talking about today. And these are topic aliases, shared subscriptions, the request response pattern, user properties, session and message expiry, payload type descriptors, and also enhanced authentication. And my goal is to show you how these specific features are actually already today being used in real use cases in the real world. So not trying to be as close as possible to the reality here and sharing my experience gained from supporting our customers. So yeah, let's start with this deep dive, and also looking forward to, of course, hearing your comments and answers afterwards. But let's start. So first feature I want to be talking about is the topic aliases. These are negotiated during connection establishment between broker and client, so they always are valid for one particular connection and not like end-to-end or broker-wide. And they can be used to exchange a topic string with an integer for communication for the length of one particular connection. This can help, of course, to lower the latency and also limit the overall data consumption in high frequency messaging scenarios. This will unburden the bandwidth usage for a network. So you see it from the source of the provider of the network, and also as a consumer, of course, this can help save data. Here is a quick illustration of how this goes. So here you can see a publish is sent with this is the topic name, and now subsequent publishes, instead of the topic name will be an empty string, and instead there will be a single integer being sent in this particular scenario for all the consequent messages pertaining to the same topic. And it's very important to note that right, so we were talking about this publishing client here, and the broker and this client negotiated this topic alias. If we go back, right, so this topic string is now aliased with the integer 1. So the broker knows that all the publishers incoming using the topic aliases 1 from this particular client belong to the topic we saw before. But now if the broker forwards this this publish to, for example, this subscriber, it will reuse the original topic name. This is again a feature that only persists for a living connection. And what is the use case that where this particular feature already helps solve? Yeah, quite the interesting and difficult use case, and this is the so-called V2X. Few words about it. So what V2X means? It means vehicle to anything communication. This is something that, when we talk about smart cities, for example, this is being used. What does it mean? It means basically, vehicles and surrounding infrastructure, or even surrounding people, communicate with one another. There's a variety of services that can be used for within the V2X context. One that's certainly very important that you read about, and that also we have seen with several customers, is basically a pre-warning system for pedestrians, for example, if cars come around corners too quickly. And what's important here is that we have a high frequency of messaging. So typically we're talking about here 10 hertz. So 10 messages per second are sent by various communicators in this V2X system. So this could be traffic lights, could be cars, could be sensors, etc. And also, of course, what we see here with this V2X is typically you see some sort of geolocation type topic structure, and and then within one geolocation you have, of course, different types of services, and they could be, for example, also separated into basic services, premium services, etc. And I'm going here, but with a calculation with one example here. So we have this topic is called Europe, Sweden, Stockholm, Northeast, tile 1-to-1 priority pedestrian alert. So this is just this is not a real life topic that I saw with any of our customers. This was just an example to show you how the topic lights visual can work. So these are 68 characters, 68 UTF-8 characters. So this will use 68 bytes of every publish message if you send this topic string with the publish, and instead we substituted with a single integer consuming only 4 bytes. So this means we can save 64 bytes for every message that is being sent. Now, if we talk about roughly 10,000 cars being serviced and by a single broker, for example, sending messages at 10 hertz, this is roughly, please don't calculate it more exactly, or there might be some, this is just rounded up. So we have 6 megabytes per second that can be saved for a single sensor that is sending messages, and over the months this will be 15 terabytes even. And why is this useful? Or so saving data, of course, is useful for everybody. Like let's say you're a car OEM introducing V2X. Of course, you want to limit the amount of data that you consume. If you're an internet service provider and you're trying to get your new 5G going, you don't want to overload the networks, of course. So everything you save can be helpful. And of course, if you, for example, a smart city providing a smart city service, you also want to be limiting the data usage and bandwidth here. The next feature I want to be talking about are so-called shared subscriptions. They are a client load balancing mechanism where multiple clients subscribe to and share a single topic using a special syntax. The syntax looks as follows. We have an identifier at the beginning of the topic that lets the broker know that we're talking about a shared subscription. Then this is the shared subscription or group identifier, and then the actual topic arrives. Now, if you look at this particular example, we have here a broker, a publishing client that uses topic status as the publishing topic, and then here we have a regular subscriber that is directly subscribed to the topic status, and then we have here a shared subscription group that are both using this string in their subscription, resulting in having 2 clients of the same shared subscription group subscribe to topic status. Now, if you see this topic, this publish is being published on this topic status, and if you now look at the distribution of it, you see one incoming message gets sent, of course, to this client and to one of these group members. And if you see then the second incoming message will also be sent again to this client and then to this client. And these clients, and it can be an arbitrary number here, we have 2, but we can have, of course, have more than 2. They will share the load, and it will be alternating which one gets it. And here's a quick example of how this could work, right? So let's imagine you have a scenario where you have some machines, they produce some data, and you have a subscriber that might, for example, here, first of all, display the data, but also write the data to an external database. Now, in this case, you have this single client serving the database, and this means that this single client needs to be able to handle all the incoming message, including the processing of the messages. Whereas what we see here, we have a group of 3 clients that in an alternating fashion receive the messages and can then write them to the database. So it means they have 3 times more time to actually do the database write before they potentially get into trouble. And this says, of course, as it always is, you could of course here introduce some extra logic and implement some sort of queuing mechanism in terms of the database is too slow and still solve this case, but this helps you basically not having to do that. And some other benefits is that shared subscriptions bring is that you get a scalable consumer infrastructure. So what we saw there in the slide before, now that we had 3 subscribers, but let's say you have a use case where you have ups and downs in terms of data that is produced. You could then even think about scaling up the consumers to a higher number when necessary. Even if you have some slow processing logic, we could talk about having to open the packet, manipulate the payload in some way, and then write it just to a slow system, and then necessarily waiting for the write to be complete. You can still achieve a high message throughput because you can scale up and distribute the load to multiple clients processing the message. Of course, another great benefit that you get from this is that your consumers can also have high availability. So if you have a shared subscription between, let's say, multiple Docker containers, if one of the containers goes down, it is no problem because the others will still take over consuming the messages. And and this can really enable very large high volume message throughput. Here is the example. Excuse me, I'll take a sip of water here. Here's the example that I want to share with you is a vehicle telemetry persistence. So we're talking about a connected car use case here, where up to tens of millions of concurrently connected cars are sending telemetry data of any kind. So for example, let's say motor engine heat, right? For example, or velocity, or whichever have you. And they're sending it on individual topics that for, make it more easy. So typically cars would use their own VIN and then just add some additional info, in this case, telemetry. And on the back end, now we have a shared wildcard subscriber. I just, I put this here in the shared subscriber group data lake, and then we use the single level wildcard that MQTT has and subscribe to the telemetry data of all the vehicles sending the data. And now we take this data and we persist it to a single data source. Such as a Hadoop cluster, for example, or whichever technology and for data lake you are preferring. And by doing this, you have a scalable and secure way of collecting all this data in near real time and getting it into your processing mechanisms, and then this enables you then to have a central place where all the information is stored, and you can you can do various data science with it, such as predictive maintenance, for example. And yeah, this is really cool. And without shared subscriptions, this wouldn't really be possible in this way for larger fleets, because at some point a single consumer is no longer capable of handling all the incoming messages. Again, like always, of course, you could like partition the topics and use multiple subscribers and stuff like that, but it just makes it much more convenient and scalable. Now, the next feature I want to be talking about is the request response pattern. And just to be, so what is the request response pattern? It's a pattern that's got introduced into the MQTT protocol that was already being used before, where you implement a so-called business acknowledgement that allows end-to-end acknowledgement in a pub/sub asynchronous messaging situation. And with the introduction of the request response pattern to the protocol, this is now something that is really extensible and dynamic and transparent. You could solve this otherwise. I will show you soon how, but you needed to basically have to identify and negotiate how you do it within your use case in a closed environment. And and this is, even though it's request response, and this is still, of course, still a fully asynchronous messaging. So it's not, it has nothing to do with the request response that is known from protocols such as HTTP. What are the benefits? Well, the benefits are that you get, or it enables you to have a end-to-end guaranteed message delivery, which a pub/sub protocol like MQTT does not provide out of the box. And this can be very useful when you have situations where you, for example, deal with very sensitive commands, right? So the example we're going to be looking here is locking or unlocking a door, maybe changing the temperature in a smart home scenario. But this could also be used when you just send very sensitive or important pieces of data, and you really need to make sure that they eventually get written to a database. And you could also use this pattern. And also this pattern allows you not only to make sure that these commands, to know that these commands arrived, but also, of course, to audit the success state of such commands. Here's the example for it. So this would be a situation where you have a smart car, or not a smart car, a car with connectivity functionality, and you are able to open the door with your, in this case, we show the HiveMQ MQTT client, which would suggest this is an Android application on your phone. And now we have a series of events that happen. So first off, the client that is sending the command subscribes to this topic, which is the result topic. Now, the car also subscribes to the remote unlock command topic, because it knows here on this topic, I expect receiving commands, or particular the remote unlock command. Now the client sends a publish on the remote unlock command topic, and it puts into the publish packet or the response topic, so the topic on which a response is expected. And also, of course, it puts a correlation ID, so that in case of multiple commands, you know which command the result refers to. Now the broker sends the publish with all the information we just talked about to the car, because the car is subscribed. And now the car executes the command. In this case, we had a successful unlock. So this will be in the payload, and correlation ID is set. We send the topic back, and now the client knows, okay, this remote unlock was successful. And again, of course, you could implement this logic by knowing the result topic beforehand, and by adding the correlation ID somehow to the payload and reading it at the car, and so on and so forth. So this pattern was used before the introduction with MQTT5 already. But the cool thing about MQTT5 is that now this is enabled actually also for multi-vendor, multi-team situation, and you can basically dynamically react to publishers that have a response topic, and then just respond to it, and you didn't even have to know beforehand that for a certain service or for a certain topic, responses might be necessary. Now, the next feature I want to be talking about is one that looks small, but actually I still believe, I said this already 2 years ago when I talked about MQTT5, I believe this is probably the biggest potential, and we're not yet there. Everybody used up all of the potential for this feature, but it's the user properties, which is a arbitrary number of key value string pairs that can be added to almost any MQTT packet. So exempt are, so both ping packets are exempt of it, and I think that's it. I think everything but the ping packets, you can add these user properties to the MQTT packets, and in this way, again, the extensibility is near endless, and the ideas just we will see what people will come up with them. I'm curious, absolutely. And if you actually here have already introduced user properties in some way, I would be very interested if you could write something about it in the QA section, and we could talk about it in the QA session. And yeah, this is a feature other protocols like Kafka or HTTP have these. They're called headers in these cases, but it's the same principle. So here we have, for example, a example here. So we have one publish that has a user property with the used schema here is JSON. Here it's XML. Here, for example, we could have you could add information about what region a publisher is coming from, if you have like a multi-regional deployment or use case. And here, for example, you could so if you what this means is maybe you use the same topic, and some of the data should be displayed where other data should be persisted, and in this way you can add the user properties, and the receiving client can already from the packet headers know how to further process the packet. Yeah, oh yeah, here's the other version of it. And the use case that I have already seen implemented, and also see customers wanting to implement, trying to implement, and something that's going to provide tremendous value in the future is tracing. So one of the challenges, of course, with any asynchronous pops up messaging like MQTT is that there's no end-to-end traceability that's inherent to the protocol, which just makes sense to the end-to-end nature of the messaging, which make it very difficult. Of course, in some situations, you can at least use the topic structure to have some type of traceability, of course, by, for example, implementing client IDs in the topics. But again, this is not really extensible, because you need to know beforehand. And also, the this only refers to what's happening on the broker itself. But with these, if you do have some messaging ID that you can just add to publish packets and then forward to publish packets that are further processed, you get real end-to-end tracing capabilities, and you can even potentially have this across multiple systems. So like we talked about, so you could, for example, if some certain action or message is triggered with an HTTP post request, and then forwarded on a JavaScript client via MQTT or WebSockets, for example, you can include the user properties that were part of the original HTTP request, and then forward them through the MQTT system, and then potentially even they might end up at some point in something like Kafka, and then you could still convert them into a Kafka header field, and so you would really have the end-to-end, even across system capabilities of tracing packets or tracing commands, tracing events. Right? It's not only about the MQTT message. It's about more, and this can, for example, allow you to use the MQTT broker as a central communications hub to identify potential problems in surrounding systems. And of course, also what one thing I've seen this used for is it really gives you some idea of the performance of your system, because you can for example forward timestamps from the start of your journey, so to speak, and then have a real end-to-end latency test capabilities. So this is for example, this is what the HiveMQ Swarm load testing tool utilizes user properties in this exact way, where the sender sets a timestamp, and then the receiver calculates the end-to-end latency by reading this timestamp. Now let's talk about session and message expiry. So these are two separate features, but I put them together here. The message expiry is sent by the publishing client in the publish message, and the session expiry is sent in the connect packet by a connecting client. So these expiry intervals set in seconds when a session or a message expires, and when do sessions or messages expire? They expire particularly when they are no longer used. So for sessions, it means that a client is offline and chose the persistent session option, so not a clean session. And for publishes, they can expire for two reasons. One reason is also that the receiving client of the publisher is offline, or the receiving client might be overloaded in some way and not send the necessary acknowledgement for a publish, and then it would also expire at some point. What are the benefits of these two nifty little features? So you can really, and this is something we will see in the hands-on example, you can really see that different types of messages can have different importance, right? So as we will see in the example, some messages need to be kept on the broker in case of an offline client for longer times than other ones. And it also is a good way of having an just built-in housekeeping for decommissioned devices, right? So when designing a system, you could say, okay, I know that if my devices won't be coming back for example 14 days, it's just what we put here, or you could do 30 days, then the session for this device will be removed, and the device still comes back, then it just has to create a new session. And not only will this of course help you with limiting persistent needs on your broker, but also it's a potential security measure, because just if someone finds an old IoT device somewhere and connects it to a broker, it won't be able to receive year-old messages that were still persisted for the client. And here's one example that I really want to talk about. This should be a premium navigation system that a connected car provider has. And when we look here, we have a traffic information, and this car is currently offline, right? And then we will discard the traffic information because, 5 minutes later or 30 minutes later, while the car was offline, this information is no longer relevant. So there's no benefit in sending it to the client. Whereas here we have a different type of message, and this message is, hey, there's a new firmware update for your navigation software. Please download and install it. Here is the link, for example, to download the new firmware. Now, this particular message will be stored on the broker much longer, because it has a much longer relevancy period, and eventually when the car reconnects, it will receive this message. Next feature I want to be talking about is the payload type description. So this is actually a combination of two separate attributes in the publish packet. Those are called payload format indicator and content type. Payload format indicator sets whether or not a payload is binary or UTF-8 valid. And then in case of UTF-8, you can describe the payload in an arbitrary manner using the content type. Here's an example. So again, we have here the payload format indicator of this publish packet indicates it is an UTF-8 encoded payload. This particular one, you can use there. So there's no, this is similar to like MIME times, but there's no like set definition of what you can use here. So you can write here whatever. In this particular case, it's called this solar panel schema version 1.0. Or you could, for example, so typical payload or content types would be JSON or XML. And yeah, the benefits are here that you can really support multiple standards and multiple schemas in a single deployment. Also, this really helps with cross-vendor or cross-team use cases, because you can just have a central information how certain schemas look and how you have to process them and build your applications accordingly, that they can handle multiple types, and you don't have to negotiate beforehand with all the participants of the use case. You can also have a sort of version control for messaging, right? It's quite realistic that the messaging or the message schemas improve over time based on maybe some customer feedback. So then you can see how it evolves, but you could still have older versions of your devices to participate in on the same brokers. If you want to describe the content type of a binary payload more precisely than just saying it's binary, you could, for example, utilize user properties in this case. And one example I can share here is actually a smart toll booth company that we work with, and they have a certain set of cameras and information, and what their situation is that the topic structure is very limited due to some devices participating in the use case. So they're using the same topics for sending, for example, just text lists of license plates, or sometimes even actual pictures of the car in front of the toll booth. And now using these payload descriptors, they can ensure that whenever the messages arrive at the back end, without having to first, not without a trial and error approach, they can actually know how to process and parse each of the different, each of the different payload types. So this was actually a huge relief for them in this particular use case. And lastly, I want to be talking about the enhanced authentication. This is a new feature of MQTT5. So an additional packet, the so-called auth packet, got introduced, and it can be used for a challenge response authentication. This is best shown and not explained. So after the connect, within the connect packet, the client can basically set which authentication method it wants to use, and then send a set of authentication data. And now the broker sends a challenge, so to speak, for this authentication message, for example, to the client, and then it can answer in a response. And this could even be, this is the easiest type of challenge response authentication. Could be even more iterations of this, depending on how secure, of course, you want this to be. So, and eventually, once the authentication is done, then the connect, in this case, successful connection is done. And so here I don't really have like a very precise use case, but I think this makes it clear here. So really the benefits here, the way I see it, the biggest benefit here is that it allows integrating modern IoT systems, modern MQTT clients in some infrastructure where you have enterprise-grade security already in place, such as Kerberos, for example. And this can help you from having to introduce a separate authentication authorization infrastructure and system for your IoT devices. Here we have a list of resources that you can check out. If you want to know more about the MQTT5, you can read our blog post series, watch our video series, and actually try out the HiveMQ Cloud Broker, or download a local version of HiveMQ to check out. Okay, I think it's over to you now, Jesheri.
Thank you so much, Florian. We have so many interesting questions coming up. I will read them out one by one. Maybe we'll not be able to cover all the questions here. We'll definitely get back at a later point of time. We'll answer them. So let's take the first question. So Emily is asking, I think this question is in context of topic aliases. So that the topic aliases is that it is only used when a client is publishing, or is it used when a client is subscribing as well?
So it can be used in both cases, right? So every time, as long as the broker and the client negotiate that they want to be using topic aliases, then also the broker can publish subsequent messages using the topic alias instead of the string. So it works in both ways. You have to really think here in terms of sender and receiver, and not so much publisher and subscriber. And whoever is the sender, which can be the client or publisher, defines the topic alias, but always between the client and the broker, they negotiate how many topic aliases they are willing to use.
Thank you, Florian. So the next question is also around topic aliases. So it's from an anonymous attendee. Regarding the use of aliases, how does this differ from using the Sparkplug B payload?
I don't understand the question.
Okay.
But I mean, sorry, I don't understand the question.
Okay.
I can encourage if you want to be talking about Sparkplug and such. We have a community forum with a Sparkplug section where we're happy to get into some deeper discussion. But I feel this would require some back and forth to get to the bottom of the question. So I don't think we can answer it here live.
Yeah. There are so many questions.
So I see a question here I want to quickly answer. Can topic aliasing work with MQTT topic wildcards? Short answer is no, because topic aliases are used in published packets only, and published packets must not contain wildcards.
Cool. We have a very interesting question from Oliver. He's asking, can we use MQTT 3 and MQTT 5 in the same deployment?
That's a good question. So based on the protocol itself is not backwards compatible, but serious MQTT brokers such as HiveMQ, but also others, will allow a heterogeneous deployment of MQTT 3 and MQTT 5 together. At HiveMQ specifically, we took great care to, with some broker features and also with our extension SDK, even allow the use of some aspects of many of the MQTT5 features, even when you're using MQTT3 clients.
Thank you. So the next question from Eric Blankenhorn, he's asking, how is request response different from QoS2?
So in short, the difference is the QoS flow is always from sender to receiver. But so if you're, let's call it publisher, broker, subscriber again, and you have the QoS2, of course, lets you know that when you send the message as the publisher, that it has in fact when it has in fact been received by the broker, once the broker sends the pubcomp packet. But you cannot, there's no technical way to know when or even if it receives if the subscriber receives the packet. So there's no end-to-end from publisher to subscriber. Quality of service cannot work because it's it pops up. You couldn't even know as a publisher how many subscribers there are for the topic, right? So, and this is how you can, or why you introduce the I'm having some echo here, Cheshire. So that's why you introduce the request response pattern to gain end-to-end acknowledgements.
Thank you, Florian. The next question is around V2X. Shan Desai is asking, in V2X communication, how does a vehicle actually discover an MQTT broker? Making the broker highly available is one thing, but is there a pattern in MQTT 5 to help discover dynamic lines connect to such high availability brokers?
So there's no again, I'm not sure if I understand the question correctly or if I can properly answer it here in this capacity, but there is not a feature in MQTT5 that allows a client to discover other clients. So I'm not sure, but I mean, so how this is done and how I would recommend doing this is using some type of load balancer that does the discovery, and the cars only need to know the endpoint of the load balancer.
Thank you. There is one more question from Emily. He is asking, he's a little confused with session and message expiry. MQTT 3.1.1 has persistent connections and retain messages. There seem to be some overlap with functionality for sessions and message expiry. Could you explain how these relate and if they overlap?
Absolutely, I'm happy to explain. They certainly do not overlap. It's an augmentation for this particular feature set. Or for example, this feature set and also queued messages for persistent sessions. So in MQTT 3.1 or .11, doesn't matter, both sessions as well as retained messages never expired, right? So if I send a retained message on a topic, for example, once, and the broker runs for 10 years, 10 years later, the retained message will still be there. And same goes for if I connect a client with a persistent session, which in this case would be clean session equals false in the connect packet in MP3. And this session would never be cleared from the broker. And or for example, go thirdly into the queued messages. If I have a persistent session, the client disconnects, I have a subscription that is called service level 1 or higher, and a message arrives on the broker will queue this message for the client and wait for the client to reconnect to deliver it. And now neither the session nor the messages will ever be cleaned from the broker. And this is where the session and message expiry comes into play, where you can now tell the broker, please keep this message for however many seconds I define. After that, you're free to remove it. So I hope that helped with the understanding.
Thank you. There's one more interesting question. Hero Wonders is asking, I think the context is around payload type descriptors, is asking, is it possible to negotiate an alias for that content type?
So the content type can be completely arbitrary. It just can be any string. It must be a string, but that's the only. So you can use what if you are in your particular use case want to be using a alias type content type, maybe for security reasons or whatever concerns, you're absolutely allowed to, and you absolutely can. But it depends on what you want from a use case. If you want it to be more open and more extensible, then it probably makes sense to have less obfuscated and more clear content types. So yeah.
Thank you. So Emily has one more question. What are the various levels of enhanced authentication?
So I mean, there's not really levels to it, but depending on. So if you're interested in this kind of topic, I encourage you to Google challenge response authentication. So for I mean, an easy example, for example, from the real world that one knows, would be using an RSA token, right? So if you have a two-factor authentication system somewhere, you log in, and then you give them the token, whatever's on the token, and then they verify that because they also know what the token is supposed to be at what time, right? Or I don't know. So beforehand, so this is always a two-step authentication. So for example, the authentication server knows that your calculation is times 7, right? So now then the authentication server sends you a 3 and expects a 21 back from you. And this is what you call challenge response. And the multiple levels just refer to, there could be back and forth, or it could just be a back and forth. So that's what that means. But this is really it's very, very particular and refers to what kind of needs you have. So if you don't, for example, have a SASL or Scrum system in place, and you're looking for authentication methods for your IoT devices, there are typically better approaches. So one thing that I would recommend looking into if you're looking to set up a new system would be the use of OAuth 2.0 and so-called JSON web tokens that already in themselves provide a multi-layered authentication functionality, and also give lots of ways for authorization.
Thank you. There is one more interesting question around MQTT5 and MQTT3. So Sebastian Fernandez is asking, can MQTT5 clients subscribe to messages published by MQTT3 publishers using shared subscriptions?
So I can only talk, of course, about in detail about how HiveMQ solves this. It might be different for different MQTT brokers, but for HiveMQ, they absolutely can. Like I said, HiveMQ strives to provide MQTT features even as much as possible to MQTT3 clients. Some of them, of course, we just cannot, right? For example, we couldn't introduce a payload format indicator in the published packet, because then this would be a protocol violation seen from the client. But a feature like shared subscription works also for MQTT3 clients fully. So even an MQTT3 client could also use a shared subscription when using HiveMQ.
Cool. We still have time to take a couple of questions. So the next question is from Tanmay Sathe. Is there any standard or best practice for payload type descriptor?
So not that I'm aware of. Like I tried to allude to earlier. The way I see it, you have two different approaches. So either you want to be as clear as possible and really, type out the exact whatever company name, JSON schema, version number, or you might want to be a little bit more obfuscated in there, meaning you use some type of alias and maybe just type their A1, right? But then the clients know that A1 refers to a certain set of a schema, for example.
Thank you, Florian. And there is one question on security. This question is from Subramaniam G. Does authentication happens in secure manner, TLS, encrypted, or in any form?
So for this, I think we have to go a little bit further back, right? So MQTT is an application layer protocol that is built on TCP/IP on the transport layer. So what happens with every MQTT connection is that underneath it there lies a TCP connection that is first established, and with this TCP connection, you can and should, or in production, one could argue, must introduce a TLS for the connection establishment. So this happens before the MQTT level authentication happens. If you're interested in this, I could only encourage you to check out the HiveMQ blog. I think 1 or 2 weeks ago, I published an article covering these encryption and authentication topic from my point of view, what you should do and how you can utilize MQTT to ensure you have a secure IoT communication.
Okay. Thank you, Florian. We are actually running out of time, so we will wrap it up now, but we will answer all your questions at a later point of time through email, or maybe we will post it on our community forum. You can check it out, but we'll definitely answer them all. So thank you, everyone. We hope you all enjoyed this session. If you'd like to watch it again, we will soon upload the recorded webinar on our YouTube channel. And if you have any more questions, you can reach out to our community platform. Thank you, everyone. Thanks, Florian. Thanks for tuning in.
Thank you, Cheshire. Thanks, everybody. Have a great day. Bye.
Bye-bye.